Alright, so this lesson is pretty much just like the last one, except we're going to use three new different ones. Instead of the SSS and SAS, we're going to use ASA, AAS, and HL. So same thing as before. We're going to apply ASA, AAS, and HL to construct triangles, improve, and solve problems. Prove triangles are congruent by using those three. There's your vocab. Alright, so an included side is the common side of two consecutive angles in a polygon. The following postulate uses the idea of an included side. So notice here, this green side is the included side of the two angles. So angle, angle, the side in between it is called the included side. Alright, so the ASA postulate is basically, like I said, it's the same thing that we were doing before. You have to have an angle, a side, and an angle paired up with another angle, a side, and an angle. These angles have to match up, the sides have to match up, and the angles have to match up. Alright, so determine if you can use ASA to prove the triangles are congruent. So I see I've got an angle here and an angle here. An angle here and an angle here. I know because of the reflexive property, this side is going to be congruent between both. So I do have two angles and a side, but are they in the right order is what you have to figure out. So you have to go angle, side, angle. So the side between the two angles is this side and this side. They don't tell us that this is congruent, so we cannot assume that they are. So no, we don't have enough info. Had they told us this was congruent to this, then we could say, yeah, it's ASA. But because it's not, it has to be in that order, ASA. Not A, skip a side and skip an angle and then go side angle. It has to be angle, side, angle. Okay, so again, same thing with AAS. These are just the different ways we can use them. We have ASA, now we have AAS, angle, angle, side. It's pretty self-explanatory. If you have an angle, two angles paired up, followed by another angle, followed by another side, then you got angle, angle, side. Alright, so let's prove this. This is supposed to say, use AAS to prove the triangle is congruent, given that JL bisects angle KML and angle K is congruent to angle M. Prove that JKL is congruent to triangle JML. Alright, so let's fill in the information that they do give us. They do already have that the angles are congruent. That is marked for us. Now I'm going to go ahead and fill in this information about the fact that JL bisects angle KLM. So here's JL, and it's going to bisect KLM. KLM is right here. So this big angle gets cut in half equally. So since it gets cut in half equally, those two are congruent. Alright, and I've got this reflexive side is another side. So I see how I'm going to get my proof. I've got an angle, and a side. So I'm going to use angle, angle, side. So let me move this out of the way so I can do my two-column proof. So I've got JL bisect angle KLM and angle K is congruent to angle M. And that is all given. Alright, I've got the fact that JL equals JL because of reflexive. Then I've got angle KLJ is congruent to ML, angle MLJ, because the definition of a bisector. Because that bisector cut those two in half, we know that they're congruent, because the fact that they told us it's a bisector. Alright, so let's see. We've got an angle, a side, and an angle. So now I can go ahead and state my proof. Prove JKL is congruent to triangle JML. And then the fact that this was angle, angle, side, my reason is angle, angle, side. That's it. All right. The last one is hypotenuse leg, HL. And this is only for right triangles. So make sure that you do write this down, that it is for only right triangles. You have to have the right angle. The hypotenuse is always the one opposite the right angle. So in this diagram, the red line on both of these are the hypotenuse, the H, because it's opposite at the right angle. This is the right triangle. The opposite side of the right angle is the hypotenuse. So since the hypotenuse are congruent, and one of the legs are congruent, so you have to only have two on this one. So that's kind of nice, is that you only have to have two pieces of information. You know that the hypotenuse are congruent and that a leg is congruent. So that is enough information to tell you that the two triangles are congruent. All right, determine if you can use the HL congruence theorem to prove the triangle's congruent. If not, tell what else you need to know. Well, first of all, I do see that we do have a right angle, so that's good. That's like a start. Notice, since this is a right angle, this is going to be a right angle because this is a straight line, and straight lines add up to 180. These are both going to be 90. Since this is 90, this has to be 90. Alright, so they're both 90-degree triangles, so we're good so far. Now I need to see if I've got enough else information. So I do have the hypotenuse of both. These are opposite the right angle, so I do have two H's. I have the H part. Notice also I've got a leg in common between both of them. This is the reflexive leg, so I could say that it does have the leg, so it has the legs in common and the hypotenuse. So, yes, can use HL. And that's it.